where we should be. You can look at your notes if you want to, but try not to for just a minute, and let's see if we can list all of our properties of parallelograms. Try to do it without looking at your notes to see if you can remember what those properties were. So starting with the definition, what did the definition tell us? Dad? Very good. So, and the way we wrote it in the notes was opposite sides are parallel. But it is a quadrilateral that has two pairs of parallel sides. Okay, what was another property of a parallelogram? Anybody? Opposite sides are congruent. You can just shout it out. Opposite sides are congruent. What was another one? Opposite angles are congruent. What else? Very good. Same side interior angles are supplementary. The way we wrote that was consecutive angles are supplementary. Sorry, guys. Mrs. Lashley. He's here, but he's not currently in my room. Okay. I sure will. Thanks. Bye-bye. All right. And the last one, what am I missing? Perfect. Diagonals bisect each other. Remember that you are going to have to eventually know these 5 properties. You have them on a property sheet. If you have not gotten that property sheet back out, get that out too, because we're going to add to it today as we learn more quadrilaterals. So wait on you while you get that out, and then we'll start looking at some problems. So basically, the big idea is going to be each shape is going to have some properties, and then you're going to have to apply those properties to a picture to find some missing measurements, whether it's side lengths, diagonal lengths, angle measures. I had a student from 4th period, I think, that came in this morning, and she had already worked on the 6-2 textbook page, even though I had told you guys you don't have to worry about it. We haven't gotten that far. Just work on trying to memorize these. She'd already went ahead and found that it was pretty easy to work through those problems just using these properties. So hopefully you'll feel that way once you look at the problems. So what is this telling me that we have here? A parallelogram. Remember that symbol is going to tell you that it is a parallelogram, and they want us to find the length of CF. So we're looking for this side. They tell us that DE is 74 millimeters, and that DG is 31 millimeters. And FCD, this big angle here, is 42 degrees. And so our goal on this problem, but if you'll flip in your notes, you'll see that there's several questions that go with this one picture, okay? So the first question we have is, what is CF? What would CF have to be? 74 millimeters. Which property are we using to determine that? Opposite sides are congruent. So you're just looking at what is a property that I can use here and then applying it to your picture. So opposite sides have to be equal, so CF is 74 millimeters. Remember, you do not put a line segment above it when you're using the equal sign. Okay, and they should be pretty easy like that. You're just applying those properties. Trey, I put a note on the desk for you. She called for you. All right, next one is the exact same picture. So this time we're looking for EFC. EFC. So I'm going to relabel what we wrote on our picture a while ago. FCD was given to be 42 degrees. DE was 74 millimeters, and DG was 31 millimeters. So relisting that information, and now we're looking for EFC. How can we find EFC? Very good. Do you guys understand what that's saying? Those two angles are supposed to be supplementary because they're consecutive. So you just have to subtract 42 from 180 to find that big EFC. What is 180 minus 42? 138 degrees. Any questions on that one? Okay. Should be the exact same picture, but a different question. Go ahead, you and your partner, and answer the next one on your own. Okay, raise your hand if you have an answer. All right, go ahead, Corbin, and tell me what you got. 62 millimeters? Can you explain to me how you got 62 millimeters? Very good. So remember, your property in a parallelogram is your diagonals bisect each other. If they bisect each other, then that means they split each other into two congruent parts. So if this is 31, this has to be 31, and then we add 31 plus 31 to get 62. Any questions on that one? All right, so if we look at the next examples that are in your notes, still just applying those properties, this time they want us to find YZ. When you look at this problem, how do you know it's a parallelogram? It's because it tells you it's a parallelogram. When we get to the end of the chapter, we're going to have so many different quadrilaterals that you've got to make sure you know which quadrilateral you're talking about. So just want to make sure that you're looking for, how do I know what shape I have here? So this is a parallelogram. I'm trying to find this distance. What could I do to find that distance? Exactly. And what property are you using, Emerald? Not parallel, that's true, but that's not the one we're using. What are we using? Congruent. Opposite sides are congruent. I'm going to keep asking you, how do you know that? Because part of your test, when we get to the end, is going to say, what do you know about these? Why do you know this? What property are you using? You're not going to have to write proofs, but you're going to have to back up how you know what you did. So you'll need to be able to say, set these equal because opposite sides are congruent. Okay, so I'm going to keep reminding you, why do you know that? Then we'll just solve. So what do you want to do, Ruben? Okay. Subtract 6a, so we get 2a minus 4 equals 10. What do you want to do from there, Gavin? Add 4. So 2a equals 14. We'll divide by 2, and what do we get for a? 7. Is that our answer? No, watch your directions. We're going to plug it back in for YZ. Remember, do not put a line segment above it. 8 times 7 minus 4. What do we end up with there? 52. Okay, you guys are super quiet and just a few people answering. Are we all doing okay here? Is this making sense? Okay. Next example I want us to look at, same problem, but this time what do they want you to find? Measure of angle Z. So now we look at angle Z. That's this angle right here. How can we find that angle? Very good, Caleb. And which property are you using? Very good. You're right. Consecutive angles are supplementary. So we know those two angles, Z and W, should add to be 180. So now we can go through and solve for B and then plug it in. Go ahead and do that, and we'll check your answer in 1 second. All right. Let's go with Michael. Did you get a value for B yet? Okay, are you still working on it? Okay, give you just a second. Raise your hand if you have an answer for B. Okay, I'm going to slow down for just a second. I'll give you one more so you can give that to Corbin too, sorry. Okay, let's check it now. Michael, did you get an answer for B yet? Okay, what did you get for B? 7. Hands up if you got B. B is 7. All right, so I'm not going to show my work there, but B should be 7. Plug that back in. What did you guys get for the measure of angle Z? Anybody? 65, and don't forget your degree symbol. Don't forget the little M, correct notation from last semester. Any questions about these? It's going to be like this for every shape. We're going to have a list of properties. You're going to apply those properties to pictures. You're going to solve for missing measurements. Isn't super difficult as far as the algebra or the geometry goes, but it's going to be, do you know which properties apply to which shape by the time we get to the test? To me, that's the hardest part of it, is being able to remember what goes with what, okay? There's one more example I want us to do. If you remember, I said I'm not going to make you guys do any proofs. You'll just be backing up why you know what you know, okay? But you're not going to have to write it in formal proofs. So this is the last example I want us to look at, and then we're going to move on. So if you look at this one, I went ahead and gave you a graph and plotted the points J, K, and L. But you will probably need graph paper if you have a question like this on your homework. So just like last semester, I want to encourage you to keep a little graph paper in your binder all the time. That way, if you have a homework question that requires graph paper, you're ready, okay? So read this with me. It says 3 vertices of, again, what does this mean? Parallelogram. J, K, L, M are J, K, and L. Find the coordinates of vertex M. So they're basically asking us to find the 4th point. Yes, I'm sorry, 6, 3. Okay, the one thing I want to warn you about is I have a lot of students who will do this problem. They'll plot the points and then another 6-3. Oh, it's because Haley hasn't passed them back. There they are. It's okay. We're not 2-6-3 yet, so it's okay. But when we get there, we'll be ready. This is still 6-2. Okay, you guys with me? All right, so first of all, be very careful when you plot your points that you don't just decide how you're going to connect those dots, okay? You have to connect them the way that it's been named. So the mistake I often see is students will go J, L, K, and think M is somewhere over here. But that is not how they told you to connect the dots. They said to connect J to K to L, and so M has to be somewhere over here. Does that make sense? Okay, so just be careful that you actually read the way they've named it. Okay, tell me what we know one more time about parallelograms based on their definition. Opposite sides are parallel. When we go to a graph, what do we know about parallel lines and their slopes? Careful. Which ones are opposite reciprocal? Not parallel lines. Perpendicular lines, okay? Parallel lines have what? Same slope. Parallel lines have the same slope. And we know that the opposite sides are parallel, so the opposite side should have the same slope. So what you can do is go from K to L and find that slope. And then where would you want to go to repeat that slope? Down to point J, so that you could create the opposite side with the same slope. Or you could find the slope from K down to J, and then where would you want to go to repeat that slope? Go to L and go down and right the same distance. Does that make sense? You want to draw in the sides that are opposite with the same slope. So either find the slope from K to L and do the same thing from J to get this side, or find the slope from K down to J and then go up to L and do the same thing to get to M. Do you want to do the shorter KL slope or the longer JK slope? KL, okay? So we want to go from K up to L. What is my rise and my run? 4 over 4. So we're going up 4, right 4. Don't reduce your slope. If you reduce that down to 1 and you just go up 1, right 1, that's not going to give you the correct point where M should be. Does that make sense? Okay, so you're going to go up 4, right 4, and that's going to give you the point what? 7, -4. Is that correct? Okay, so that's going to tell us where M should be, and then we can connect that and draw our parallelogram. Write your answer as the ordered pair because that's what it asked you for. So M is at 7, -4. So we're just using that idea of opposite sides parallel, and parallel lines have the same slope. So repeat the slope on the opposite side. Any questions about 6-2 parallelograms? Okay, 6-3 you're going to find is pretty easy because it's basically the same thing. They really go perfectly together. So remind me back in chapter 2, that's been a long time ago, when we had the word converse. What did converse do to a statement like if P then Q? Okay, so it switched the hypothesis and the conclusion. It said if Q then P. So basically what they're going to do in this chapter is they're going to say if it's a parallelogram, then all of these things are true. 6-3 is going to flip that, and it's going to say if any of these things are true, then it must be a parallelogram. And that's what 6-3 is all about. It's going to say, can you prove that this is a parallelogram? Are any of these things true? If so, then it's a parallelogram. It does not have to have all of these to be a parallelogram. It just has to have one of them. If the opposite sides are parallel, it's a parallelogram. They're going to give you some shortcuts even beyond this. So we're going to add in our notes one extra way to prove it's a parallelogram, and then we may change a little bit of this to make it a little shorter. Okay? But the big idea is if any of these things are true, it's a parallelogram, and that's what they're going to ask you to do. Show me it's a parallelogram. Okay? Again, I'm not going to ask you to write 2-column proofs, but I'm going to ask you to back up how you know with a property. Okay, so if you turn into your notes and look at this first chart, they're going to walk you through the ways you can prove it's a parallelogram. So on your property sheet, what you might want to do is list the ways to prove it's a parallelogram. They're basically the same 5 things, but a couple of them have a shortcut. And then there's one extra way. So there's going to be 6 ways we can prove it's a parallelogram. 5 of them are basically the same. So we're going to list those ways to prove it's a parallelogram. The first way you can prove it's a parallelogram is by its definition. If opposite sides are parallel. So if you see a shape and they've marked the opposite sides parallel, that's enough information to say it is definitely a parallelogram. And you would say, yes, because opposite sides are parallel. And that's as far as proving I'm going to make you go. Okay, so that's our first way. If our definition's true, if the opposite sides are parallel, it's a parallelogram. Okay, and I'm going to kind of skip around in your notes because I'm going to kind of try to compare it to what we did over here. So the second thing we had here was if opposite sides are congruent. That is here. If both pairs of opposite sides are congruent. The key thing is you have to have both pairs marked congruent. It can't just be one pair. And the same for the opposite sides. It has to be both pairs. I'm going to emphasize that here. Both pairs of opposite sides have to be parallel. The second way you can prove it's a parallelogram is if both pairs of opposite sides are congruent. So again, so far it's just the same thing that we have over here. The only reason I'm making you write it again is because a few of them are just a little bit shorter. So if both pairs of opposite sides are congruent, that's enough to say it's a parallelogram. You only need one of these to be true to prove it's a parallelogram. Third way you can prove it's a parallelogram is listed here. Again, it's got to be both pairs of opposite angles are congruent. Just like we have over here. Opposite angles are congruent. So if both pairs of opposite angles are congruent. It's not enough to just have one pair congruent. You have to have both pairs congruent. But if you know that, that's enough all by itself to say it's a parallelogram. Okay, the next two are going to change just a little bit. And I'm going to skip on. I'm going to come back to this one because this is extra. Come back to it in a minute. I'm going to skip on to this chart right here. So if you're looking at your notes as well there, we're on the second chart in your notes, down at the bottom left. Okay, this says consecutive angles are supplementary, right? This is going to say that if one angle is supplementary to both of its consecutive angles, that's enough to say it's a parallelogram. If you have one angle supplementary to both of its consecutive angles. So in other words, what is 180 minus x plus x? 180 minus x plus x is what? 180, right? 180 minus x plus x, what happens to that? Cancels out, we get 180. So would you agree that these two angles are supplementary? Okay, same thing if I go this direction. 180 minus x plus x is just 180. We don't know what this angle over here is. But if one angle happens to be supplementary to both of the angles that are next to it, that's enough to say it has to be a parallelogram. You don't have to have all 4 angles. Here's why. I'm going to draw a parallelogram up here. Let's say that this is 60, and this is 120, and this is 120. Would you agree these are supplementary? Okay, and these are supplementary, right? What did we learn on, what is today, Thursday? Tuesday. What did we learn about all four angles in any quadrilateral? They have to add to be 360. So if this is 120 and this is 120, that right there is 240, plus 60 is 300, right? So if this has to add to be 360 for any quadrilateral, then the only option up here for this angle is what? 60. And so then these are going to be supplementary and these are going to be supplementary. So we don't need that fourth angle because they have to add to be 360 as long as you have one angle supplementary to both of its consecutive angles. That's enough to say it's a parallelogram. Okay? So it doesn't have to be all four supplementary. That's the change. So the fourth way we can prove it's a parallelogram is if one angle is supplementary to both of its consecutive angles. And you may want to draw that picture in your notes just to make that make sense when you're looking back at it. So draw yourself a little parallelogram and write in 60 degrees, 120 degrees, and then another 120 degrees to show that you only need those three angles. And if you can't see that picture very well, it's the same picture that I drew over here. Okay? And then the fifth way to prove it's a parallelogram is similar to what we have here, but also just a little different. Actually, no, this one is exactly the same. So this one is the same. It just says if the diagonals bisect each other. So you will need that both diagonals bisect each other. So fifth way is exactly the same as what we have here. If the diagonals bisect each other. So if you look at the picture and they've marked those diagonals are bisected, that's enough to say it's got to be a parallelogram. Okay, there's one extra way to prove it's a parallelogram, and I skipped it back on that first slide. It's not a new property. There's only 5 properties of a parallelogram, but it's a sixth way to prove it, and it's a little bit of a shortcut. So the sixth way, I'm kind of running out of room there, so I'm going to come over here so you can see better. It's written right here in your notes. The sixth way to prove it's a parallelogram is if you have one pair of opposite sides, just one pair, not both pairs, but those opposite sides have to have both properties that they are parallel and congruent. The same pair has to have both properties. So if one pair of opposite sides are both parallel and congruent, that's enough to prove it's a parallelogram. I'm going to draw a picture to show you what I mean, but it's also up there on the board. So if you have a parallelogram, one pair of sides are parallel and the same pair of sides are congruent. It has to be the same pair. You cannot have this, and this is how they trick you. You can't say one side's parallel and the other pair is congruent. That is not enough to prove it's a parallelogram. Okay, it has to be the same pair of opposite sides, have both characteristics. Questions? Okay, let's work some problems. This is basically 6-3. They're just going to ask you, can you prove it's a parallelogram? And do you have one of these ways to do it? And again, most of it is the same exact thing that we talked about as far as a property. The only two changes are you only need 3 angles where one of them is supplementary to both of its angles. And then you have this shortcut here, that if one pair is both parallel and congruent, that's enough. Okay? You don't have to write 2-column proofs, but we do know that when it says show, it's all about your work. So this one's kind of a long one where you've got to show everything you do, back it up with a property. Okay? I want you to write down, back it up with a property. So you're going to show your work, and then you're going to list the property that proves to me your work proves it's a parallelogram. So start with what's in your picture. What are they giving me information about in the picture? Sides, angles, diagonals, what? Sides. So what do you think, using that picture, we could prove about the sides? Do you think we have enough information to prove the sides are parallel? Nope, it's not on a graph. We would probably need it on a graph to prove something about slope. I don't think Comp 2 starts until next week. You're welcome to go down there and talk to Ms. Stephenson, but the student I have that's in Comp, she told them that they didn't actually have to report to it until Monday. So it's kind of really just your free period. Then you could go home and come back if you check out or whatever. So you'll be in Comp 2 this period. Will you be in aid anytime, or are you? 6th hour will be aid. Okay, I'll look at your schedules and see. Yeah. Okay, yeah. So you're kind of free to do whatever you want to do. Yeah, and this, yeah. So I don't think you'll report. Will it be? Probably won't be till. Well, Monday will be a B day. I mean, an A. Yeah, the same as today. Yeah. I'm sorry. Yeah. Yep. You're welcome. Okay, you guys with me? So we can't prove that they're parallel unless it's on a graph where we could use slope. How can we prove they're parallel? Congruent. All right, so that's what we could prove. They're going to give us the value for B, so what would we need to do to show that the opposite sides are congruent? Plug it in. They're also giving us the value for A, so we can prove the other pair of sides are going to be congruent. Remember, you've got to show that both pairs are congruent to prove it's a parallelogram. When you show your work, please label your work. Don't just write a bunch of numbers all over your paper. Show what you're finding. So we're going to do this pretty quickly because I don't think it's very hard, but we're going to find each side length and then show that their opposite sides are congruent. So KL is going to be 5B plus 6. Plug in 9 for B. And tell me what we get. 51 is what Kirsten said. So we're just going to show our work and label KL equals 51. Then go to the next side. I would probably do my opposite sides together. That way that's what we're trying to show. So I would go to JM and keep plugging in that value for B. So 8 times 9 minus 21. What's 8 times 9 minus 21? 51. And then it's really great notation if you show that those two sides now are congruent. So we could say that this implies KL is congruent to JM. So we found those two distances. Now we know the opposite sides are congruent. Does that make sense? Okay, and then let's do the next two sides. So we have KJ is 15 times A, which is 3 minus 11. What do we get for KJ? 34. And then at the same time, we'll go ahead and do LM. LM is 10 times 3 plus 4. And what do we get? 34. And then again, tell me what that means. So that's telling me that KJ is now congruent to LM. And notice that notation from chapter 1. We're putting a congruent symbol, so we're putting the line segments to say that they're congruent. Then I want you to back it up with your property. How did we just prove that this is a parallelogram? Okay, so then we're going to say both pairs of opposite sides are congruent. So again, I don't want you to make it super difficult or hard, but you need to know these properties. So I want you to write down the property. It's going to help you remember it. And you're trying to show that it's a parallelogram. So show your work, back it up with a property. Questions? Okay. If you look at this one, same idea, but we're going to have to use a different property. What can we do to show it's a parallelogram? What did she say? You don't have to be there Sunday. Yeah, you do have to be there today? No, yeah. Okay, so notice in the picture what you're given. If you're kind of struggling with, I don't even know where to start. Do you know something about sides or do you know something about angles in your picture? Well, when you look, it's angles. The next thing you have to be careful about, and what I see a lot of students make a mistake on, is they try to use opposite angles are congruent. Do we know all four angles? No. So we're not going to be able to show that both pairs of opposite angles are congruent because we don't know what that fourth angle is. So you can't use this unless you know all four angles. We only know 3 of them. That means we can show that one angle is supplementary to both of its consecutive angles. So that's what we need to do. Again, label your work, plug it in, show what you get, okay? So again, I'll go through this pretty quick because I know you're probably getting tired of writing the same stuff down. So we're going to find measure of angle Q. We're going to go through and find the measure of angle R. And we're going to find the measure of angle S. So we're going to find those 3 measurements, and then we're going to show that the consecutive ones do add to be 180. So angle Q was 6y plus 7. What did they tell me y was? 6.5. So we're going to plug in 6.5. Multiply that out, add 7. Tell me what you get for angle Q. Kirsten says 46. Somebody agree with her? Yes. Okay. So I've got 46 degrees for angle Q. Are we good with that? Okay, moving on to angle R then. Angle R is 15 times x minus 16. Be careful that you're plugging in the right variable. What did they tell me x was? 10. So what do we get when we do 15 times 10 and subtract 16? 134 degrees. And then we're going to do our last angle S, 8y minus 6. What is 8 times 6.5 minus 6? 46 degrees. Then you can show it a couple of different ways from here. I'm not going to be super picky about what you show me, but I am going to be picky that you write down the property that you used. So you could either just do this, these two, 46 plus 134 equals what? 180 degrees. And then you could do the same thing over here. These two, bless you, 134 plus 46 equals 180. You could write it that way if you want to, just to show that they do add to be 180. Or you could say this, measure of angle Q plus measure of angle R equals 180. And then over here you could say measure of angle R plus measure of angle S equals 180. I'm not going to be really picky about that. I just want you to show me that you are checking to see that they add to be 180. But then I want you to write your property. So show your work, back it up with a property. Which property did we use again? Good. One angle is supplementary to both its consecutive angles. And I think the more that you write those down on the homework, the more it's going to help you study what are my properties of a parallelogram. Okay? The next examples you see in your notes are not the long ones like this, and that's what a lot of your homework will be like, are the next ones, where they're just going to ask you, oops, determine if it's a parallelogram, justify your answer. When you see this, I expect you just to back it up with one of your properties. Okay, so again, you're not writing a proof, you're just telling me which property says yes it is, or why is it not a parallelogram. So when you look at this picture, would you say this is or is not a parallelogram? It is, okay? And which property would you say backs that up? Good. One angle is supplementary to both of its consecutive angles. These two add to be 180. These two add to be 180. Again, you can't say opposite angles are congruent because you don't know this fourth angle. Okay? So we would say, yes, one angle is supplementary to both its consecutive angles. All right, look at the last one. You and your partner decide whether or not you think it's a parallelogram, and if so, which property? If not, why not? So last example here. Okay, what do you think? Yes or no? Hands up if you say yes, it's a parallelogram. Okay, hands down, hands up if you say no, it's not a parallelogram. All right, so I got a mixed decision there. So those of you that say no, why is it not a parallelogram? Okay, remember that to say it's a parallelogram, if you're using opposite angles congruent, that you have to have both pairs. One pair being congruent is not enough information. So yes, these are congruent, but we don't know anything about these two angles. Does that make sense? We don't have enough to prove that their consecutive angles are supplementary. We don't know anything about the sides at all, so we don't know if they're congruent or parallel. We don't know anything about the diagonals. So the answer would be what? No. Justify your answer. You could say something like, you need both pairs. Of opposite angles congruent. Or you could say you don't have enough information, you only have one pair of angles. Something though, back it up, don't just put no. What's your reason? Why is it not a parallelogram? Questions from those of you that said yes? Okay, we're going to look at this example that's in your notes here, but it is now algebraic. And I did not give you a picture, correct? All right, everybody needs a piece of graph paper. So jump up and make sure you have some in your binder. If you don't, grab extra. You know what? I think I'm going to skip this one. You're going to need your graph paper for the next lesson, but I'm going to skip this one because there's one similar to it on the next lesson, and I didn't ask you to do anything like this on the homework, okay? So skip this one. Let's move on to 6-4. And I'll pass out 6-4. I haven't handed you those notes, right? Okay. So that's 6-3. That's parallelograms. And we'll save the graph paper for this lesson. It's going to be similar. Oops, I keep forgetting to pass Corbin's back so you don't have to do that. And you'll need your property sheet because we're going to talk about new shapes. New shapes. Okay. So just to make sure, one more time before we move on, everybody's clear. These are your 5 properties of a parallelogram. Your homework is going to give you pictures. You're going to apply those properties, solve for missing sides and angles, just like we did. That part should be pretty easy. The algebra won't be hard. 6-3, which is going to be on this new assignment I'm going to give you, the first page, it's going to be basically either showing your work and backing it up with the property like we did. Those will be the long ones. Or it'll just be, here's a picture. Do you have enough information? Back it up with a property. Okay, so it's just, can you prove it's a parallelogram? Basically, it's the same properties. One of them, it's a shortcut because you don't have to have both pairs of consecutive angles supplementary. You just need one angle supplementary to the ones next to it. And then you've got the 6th way, which is just an extra way to prove it. Okay, if one pair is both parallel and congruent, that's enough. You don't need the other pair of sides. Are we all good with the parallelogram? Okay, because now in 6-4, we're going to talk about 3 more shapes. The rectangle, the rhombus, and the square. These are special parallelograms. They are all parallelograms. So on your property sheet, we're going to make a list. And we're going to do that first. So before we go through all the examples in the notes, we're just going to list the properties first. So start with the rectangle. Back to your property sheet, we're going to start with the rectangle and we'll list the definition first. We'll list all its properties, then we'll do the rhombus, and then we'll talk about the square. Okay? And I'm going to change a little bit in your notes. So if you'll keep your notes kind of with you as we're going through this, if you'll look at the 6-4 notes with me right here, I want you to change one thing about the definition. A rectangle is a quadrilateral. Would you agree it's got 4 sides? Okay, but we're going to change that just to save us some time and say that it is a parallelogram. We're going to be more specific. It's a quadrilateral, but it is also specifically a parallelogram with, and then here's its definition. So the definition says that the rectangle is going to have what? 4 right angles. So a rectangle has 4 right angles. But the definition also says that it is a parallelogram. So what we're going to add down here as our property of a rectangle is the rectangle has, because it's a parallelogram, it has all 5 properties of the parallelogram. The rectangle has opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and the diagonals will also bisect each other in a rectangle. So the rectangle will have all of these properties, plus the fact it has 4 right angles. So I'm going to put it has all 5 properties of a parallelogram. So right now our rectangle has 6 properties. It's got all 5 of them of the parallelogram, and it's also got 4 right angles. Are we good with that? Okay. There's not a special little symbol that they're going to use for rectangle. You can just name it A, B, C, D. They'll have to do something to show you that it's a rectangle. You don't have to write the word rectangle. You can just name the shape going around the shape. Okay, so we already wrote down this property. If you're looking at your notes, if it's a rectangle, it's also a parallelogram. So we listed that. It has all 5 properties of the parallelogram. It's got the definition that it has 4 right angles, and then the rectangle has 1 more property, and that's it. Not only does it have diagonals that bisect each other, but if you look at the rectangle, would you agree that those diagonals should be the same length? In a parallelogram, since it's slanted, does it make sense that this diagonal is longer than this diagonal? Okay, so the parallelogram shifted. Its diagonals are not congruent. But when you straighten that up and make that have 4 right angles, your diagonals are going to be congruent. So the last property for the rectangle, which will actually be its 7th property, it's got 5 here, 6 here, 1 more. It has congruent diagonals. And if you want to, you could draw yourself a picture just to make sure you understand. You're saying that these diagonals are congruent. And so to mark that, it's kind of hard to do that, probably, but we're basically saying this whole piece is congruent to this whole piece. Or if you wanted to, you could label it maybe A, B, C, D, and you're saying AC is congruent to BD. And that's it. That's the rectangle. It's basically just a parallelogram that has 2 extra properties. It's got 4 right angles and congruent diagonals. Are we okay? I'm going to give you a lot of information, so I want to make sure it's all making sense before we go too far. Okay, the next shape we're going to look at is the rhombus. So again, you're on your property sheet. We're going to list the properties. I'm going to skip examples. So if you want to turn in your notes, you can turn to where the definition of the rhombus is. So it should be on the back, I think, of the first page of your notes. And we're going to change the definition again. A rhombus is a quadrilateral, but it's going to be more specifically a what? A parallelogram. So we're going to change this to, it is a parallelogram with 4 congruent sides. So again, our definition for our rhombus is that it has 4 what? Congruent sides. Okay, a rhombus has 4 congruent sides. If you want to, you can draw yourself a picture there just to make sure you understand what you're writing. It's going to have 4 congruent sides. But we also said it's a parallelogram, so the next property that we're going to write down is that it has all 5 properties of a parallelogram, just like the rectangle. So it has all 5 properties of a parallelogram. It has 4 congruent sides, so it's got 6 properties so far, and then it's going to have 2 more. So if you flip, and again, there's no special way to show that it's a rhombus. You don't have to write the name. You can just say A, B, C, D, but they'll have to show you something to prove it's a rhombus. Okay, so it's going to have 2 more. We already wrote this first one down in your notes, that it is a parallelogram, so it's going to have all the 5 properties of a parallelogram. The next 2 properties is this one that says its diagonals will be perpendicular. Not congruent, but perpendicular. That means that if you draw in the diagonals, what are they going to make when they intersect? Right angles. So they're going to make 4 right angles here. those diagonals are going to be perpendicular. So a rhombus has perpendicular diagonals. And again, I would draw myself a picture to make sure I understand what that means. So I'm going to draw myself a rhombus and then draw in my diagonals and show that they're making right angles. You can do 4 right angles if you want to, or just 1 to show that they are perpendicular, but it's going to make 4 right angles. So keep in mind, that means it's going to have 4 what kind of triangles? 4 right triangles. You might have a problem where they ask you to find something like this side right here, and they give you the lengths of these 2 sides. What do we do if we have a right triangle and we know 2 sides and we're looking for the 3rd side? Pythagorean theorem. So you may want to make yourself a little note that you might have to use Pythagorean theorem, which is a squared plus b squared equals c squared. And it just depends. They may or may not give you problems like that, but if they do, you know from before how to solve for missing sides of a right triangle. So you can do that. Okay, last property for the rhombus is if it's a rhombus, then each diagonal will bisect a pair of opposite angles. That's wordy, so I'll show you what I mean, but let's write it down first. My marker's not very dark. Let's see if I have a better one. So last one here. The diagonals will bisect opposite angles. The diagonals bisect opposite angles. Each diagonal will bisect an opposite angle. So both of those diagonals are going to bisect the opposite angles. I'm going to draw a picture up here on the board. Hopefully you can see it at the back. So I'm going to draw a rhombus. It's kind of bad. We know it has 4 congruent sides. Here's what this is saying. If you draw in the diagonals of the rhombus, it's going to split each of those big angles into 2 congruent pieces. And we already know that the opposite angles are congruent because it's a parallelogram. So it's going to split that so that these 4 angles turn out to be congruent to each other. Are you with me there? And then the other diagonal is going to do the same thing to those opposite angles. So these angles are now going to be split into 2 congruent pieces. But since the opposite angles were congruent to start with, it's going to split it into 4 congruent pieces. Does that make sense? So again, on your picture here on your notes, these 2 are going to be congruent to these 2. So all 4 of those will be congruent. And then these blue ones will all be congruent. Okay. So we've got our properties for a rectangle, properties for a rhombus. Last one's the square. And it's probably the easiest one. So when we look at the square, again, I'm going to jump ahead in your notes to where it says square. Oh, good grief, come on. So find the definition for square. Oops, I went too far. Here's square. Okay, last property. So on your notes, use a different color. We're going to write down square. And the first one's going to be the definition. And again, we're going to change our definition for square. It is what? It's a parallelogram also. So instead of just saying it's a quadrilateral, we're going to say it's a parallelogram. And what is a square going to have for its definition? 4 right angles and 4 congruent sides. Okay, think about that with me. Which shape said that it had 4 right angles? Rectangle. And which shape had 4 congruent sides? A rhombus. So another way to say the definition of a square is that it is both a rhombus and a rectangle. The definition for a square is it has 4 right angles, which means it's a rectangle, and it has 4 congruent sides, which means it's also a rhombus. And we already know it's a parallelogram. So the square, by definition, has all properties of a rectangle, rhombus, and parallelogram. And it doesn't have any extra properties. It just has all the properties that we've learned so far. So it's a parallelogram that is also a rhombus and also a rectangle. Okay, I want you to draw a Venn diagram on your paper real quick. So on your paper somewhere, let's see, on your notes, wherever you want, properties, notes, I don't care, whatever's better for you, draw this with me. So draw a box. We're going to write in our box, quadrilaterals. We've talked about polygons, which was the big topic, but now we focused on just some quadrilaterals. Okay? Inside our quadrilaterals, we have learned 4 types of quadrilaterals. We've got the parallelogram, the rectangle, the rhombus, and the square, right? So inside our quadrilateral box, we're going to put a big circle. Leave a little space in your box over here because we're going to come back and fill some stuff in that we haven't learned yet. So inside our quadrilaterals, we've got the parallelograms. And what shapes did we say today are parallelograms? Rectangles, rhombuses, and squares. One of those is both of the other ones. Which one is both of the other ones? The square. So inside your parallelogram box, you're going to draw 2 overlapping circles. Which shape needs to go in the overlapping part? The square. So inside this little circle, we have our squares. And I drew my box too small, so you may have to make yours a little bigger than I did. So I'm going to have to just kind of shove that word in there. That says square. Yeah, do whatever you want to in your little Venn diagram, but mine's not quite big enough. And then does it matter which circle is the rectangle or the rhombus? No. So you could have a shape that is a rectangle only. You could have a shape that's a rhombus only. But if it's both a rectangle and a rhombus, then it becomes a square. That makes sense? And all of these 3 are definitely parallelograms, and all the parallelograms are definitely quadrilaterals. And so this just kind of helps us organize our thoughts. Okay, one thing I need to emphasize before we look at some problems. They're going to ask you in this chapter if you have enough information to prove that it's a rectangle, to prove that it's a rhombus, or to prove that it's a square. What was the first thing that we changed in every definition for these 3 shapes? Has to be a parallelogram. Before you can prove that it's a rectangle, you first have to prove that it is a parallelogram. Before you can prove that it's a rhombus, you're going to first have to prove that it's a parallelogram. Before you can prove that it's a square, you're going to have to first prove that it's a parallelogram. Okay? So you cannot look at your shape and say, oh, it's got 4 right angles, it has to be a rectangle. You first have to know that it's a parallelogram. I'll show you what I mean by that. So, let me think. Let's do this. When you look at that shape based on what I've given you, what property do you see there? Okay, it's got perpendicular diagonals. Do you agree that those diagonals are forming a right angle? So you might look at that picture and you might think, oh, if it's got perpendicular diagonals, it has to be what shape? A rhombus. But it's only a rhombus if it's first a parallelogram that has perpendicular diagonals. That shape on the board is not a rhombus. It does not have 4 congruent sides, and I haven't proved that it's a parallelogram yet. This shape is actually going to turn out to be, I heard someone say it, a kite. And kites also have perpendicular diagonals, but they're not parallelograms. It's a shape, and we're going to talk about it. Not today, okay? But we will. So it is one of our special quadrilaterals. It's going to go inside this quadrilateral box, but it's not a parallelogram, okay? So be careful. You've got to first show that your shape is a parallelogram before you can say that it's a rhombus or a rectangle or a square. Then if you want to say that it's a rhombus, it's got to have one of these two properties if it's a parallelogram. If you want to say it's a rectangle, then it's going to have one of these two properties once it's a parallelogram. If you want to say that it's a square, it's going to have to be all 3 shapes. You're going to have to show me it's a rectangle, show me it's a rhombus, and show me it's a parallelogram. Okay, so we'll look at some problems where I'll explain that better. Okay, that's the big idea. Let's go back to the very beginning in your notes, and we'll try some problems. That's all there is as far as information. So I think this is the first example we skipped, right? Okay, take a second, read it. What's a key word in that paragraph? Rectangular. So they're telling you this is a rectangle, which means right now you know that this shape has 7 properties. It's got all the properties of the parallelogram, it's got 4 right angles, and it's got congruent diagonals. So now you're going to use one of those properties to try to answer this question. What is HM? So what do they give us that's going to help us with that? JL, this diagonal is what? 86. Okay, how does that help me figure out the other piece of the other diagonal? Okay, rectangles have congruent diagonals. So if JL is 86, then KM has to be 86. Okay, that's helpful, but then now I still want to know what the piece of that is. How do I find that? Okay, we can divide it by 2 because a rectangle is also a parallelogram, and parallelograms diagonals bisect each other. So if it's a parallelogram, the diagonals split each other into 2 congruent parts. So we can take this 86 and we can divide it by 2 and we get 43. So HM is 43 centimeters. So do you see how you have to apply your properties? Figure out what shape you have, figure out what's true about that shape, and don't forget that all of these have these same 5 properties, okay? Any questions? All right. Basically, that's what a lot of your homework is going to be, are problems like this, where you're trying to find a missing measurement based on whatever shape it is. So now flip to this one. What shape do we have? A rhombus. Okay, the rhombus again has several properties. The rhombus, has 8 properties. It's got 4 congruent sides, perpendicular diagonals, diagonals that bisect opposite angles, and all the 5 properties of the parallelogram. We want to find TV. This is a little bit of a harder problem. So when I look there, do I know anything about line segment TV at this moment? No. But what property of a rhombus might help me? Okay, I heard Tate say it has 4 congruent sides. So that means TV is the same as what? WV and xt and xw, right? All these sides are congruent. So would you agree if I could find one of the other side lengths that's the same as TV? Okay. So what could I do to try to figure out one of the other side lengths? Mm-hmm.
So since it for the rhombus, since it like does perpendicular diagonal,
Mm-hmm.
doesn't that form a right angle? So could you use Pythagorean theorem?
You could if you knew two sides, but the fact that this is a right angle here, or this is a right angle, or this is a right angle, we don't know the lengths of these pieces of that right triangle. If we did, we could find TV by using Pythagorean theorem. So great idea. The rhombus does have perpendicular diagonals, so Reese is correct. If I had known two sides, I could have found that TV, but I don't. So now I'm kind of stuck there. So what can I use if I know TV is the same as XT and WV? Okay, if all the sides are the same, don't you agree that those opposite ones are equal then as well? Okay, so go ahead and solve for B. And I'm going to work it up here on the board while you're working it. What did you get for B? 1.3, and it's exactly 1.3, right? It's not repeating. There's no fractions to worry about. B is 1.3. We want to find TV. You said TV is the same as any of the sides, so which one do you want to plug it back in for? I probably would too. So XT is 3B plus 4. 3 times 1.3 plus 4. That gives us 3.9 plus 4. So what is XT? 7.9, which means that TV is also 7.9. Okay? The next one is a little harder, but it's the same picture. Flip it over. It's exciting. Same thing, it's a rhombus. This one's probably the hardest one. Okay, so same picture, same problem. Give me just 2 more minutes of your attention, okay? Look up here. They want us to find angle VTZ. This angle right here. And again, this may be one of the hardest ones, but it's still not terrible. So tell me what I know about this angle in relation to the rest of this picture. Okay, so reset, it's also 5a minus 5. Remember that one of your properties for a rhombus is the diagonals bisect the opposite angles. So that means that if this angle is 5a minus 5, then this angle next to it is also 5a minus 5. Is everybody okay with that? Okay, the problem is we don't know what a is, so we can't find that angle. Dad? Okay, so we do know that these angles are also going to be 5a minus 5. But because we don't know angle WVT, knowing that these are supplementary isn't going to help us, okay? But that is true. We do know that these two angles and these two angles, because these in a parallelogram are consecutive angles, would be supplementary. But this is pointed to this angle right here. What do we know about that angle right there? Okay, that goes back to this one. So what I'm going to warn you about is sometimes you're not going to have enough information to find what you're looking for right off the bat. You may have to solve for something else first. So perpendicular diagonals in a rhombus means that this angle right here is going to be what kind of angle? 90, or a right angle. So would you agree that 14a plus 20 has to equal 90 degrees? Okay, can I use that to find a? And once I know a, could I plug it in here then to find the angle I'm looking for? Okay, so notice how we had to do two steps there. We want this angle. We first had to know that these were the same, but then we were stuck. So now we're going to go back and find out what is a by using a different property. So let's subtract 20. That gives me 14a equals 70. And then divide by 14 and tell me what you get for a. A is 5. Again, we didn't need to know anything about this angle, but that's what we're going to have to use to find the angle we want to find. So we figure out what A is, and now we're just going to substitute that in since Tate reminded us that these two angles should be the same. So what is 5 times 5 minus 5? So we get 25 minus 5 is 20. So the measure of angle VTZ is 20 degrees. The entire chapter is basically, here's some properties, apply the properties. You're gonna